section 4.1, before I even begin, I'm going to kind of reiterate something you probably heard me say before a couple of times. First off, you need a pencil. All right, yes, I know I have some things written in ink in here, but even I'm using a pencil in this video. Secondly, you need a straight edge. Did I mention you need a pencil? Here's the thing about a pencil. You need a pencil sharpener because you need a sharp point as much as you possibly can. This seems silly, I know, but the thing is, as we are trying to make sure, as we graph these and find solutions using our graphs, if our pencil is not precise and we are not precise in our movements, we can easily make a mistake. It can happen. I know it happens. I've seen it happen, and somebody's gonna do it again. But consider this your one and only, not your one and only warning, but just consider this a warning and a friendly reminder. Pencil, keep it sharp, have a pencil sharpener nearby, and have you a straight edge of some sort. Now, with that being said, what we're going to be doing today is called solving systems of linear equations by graphing. What in the world is all that about? So first off, what is a system of linear equations? It's a set of two more linear equations with the same variable. Giving you an example. Y is equal to x plus 1 and y is equal to 2x minus 7. They have the same variables. I'm going to put an S there. All right. They both have y, they both have x's, okay? So nothing complicated there. Now, what we have to do is solve this and find a solution. And what we do is the solution is an ordered pair that is a solution, use that word again, to each equation in the system. So I've done the work for you on this, so I've already given you the solution. Here is my ordered pair. This ordered pair is the solution for both of these equations, and we can kind of prove that. We know that x is 8, and we know that y is 9, so we can plug this in. All right, so I'm going to plug it in. 9 is equal to 8 plus 1. Does 9 equal to 8 plus 1? Yes, it does. So this ordered pair is a solution to this. And then the same thing happens here. We have 9 is equal to 2 times 8 minus 7. Well, that's 9 is equal to 16 minus 7. Is 16 minus 7 equal to 9? Yes, it is. So this is also a solution to this. And because this ordered pair is a solution to both of these equations, it is the solution to this system of linear equations. All right, just kind of keep that in mind. The ordered pair is the solution to both equations, and in all truth and honesty, it might be 3 or more equations, but you won't be doing that anytime soon, not even probably till college, if you get a third system. But anyway, that's besides the point. So how did I even get this number in the first place? How did I get that ordered pair? Well, there are multiple ways of doing it. Today I'm only cover 2 things. First off is what we call the break-even point. It's what we also known as the table method. It's actually the most boring and the most aggravating method, but a lot of people, especially those who are just beginning to understand this, like it. The next one is graphing. This is also one of those methods that you need to know. And it's tedious, it's annoying a little bit, but I will be honest with you, once you see the algebraic way of solving these things, you're not going to want to graph it anymore. But for now, we're going to show you break-even point, aka the table method, and graphing. So let's go ahead and get right straight into this thing. All right, so here we have question number 1. Use the table to find the break-even point. Check your solution. I've given you C is equal to 25x plus 210, and then I've given you the other one, R is equal to 60x. Now, my job is to basically find out when these two numbers break even. Well, what do you mean? Well, it's easier to show you than to tell you. All right, so notice up in this table, I've got a bunch of x values here. My job is to find out what C is equal to when x is 0. So basically, I'm just going to kind of do a little example. I'm going to go 25, and I'll put 0 in the place of x. And then I'm going to add 210. All right, and this is what C is equal. I'm going to work this all out, and I get C is equal to 0 plus 210, and C is equal to 210. So that's my first point. All right, and I'm going to do the same thing with R. So R is equal to 60 times 0, and r is equal to 0. Okay, so I did that, and I'm going to literally do this with each one of these inside of this table. So let's go ahead and do that right now. 235, hey, I'm going to help you out a little bit to kind of speed up this process, just kind of copy what I've got going on. I think this is pretty much self-explanatory how I am doing it. It's just plugging the numbers in and seeing what comes out. All right, and there's the mystical fairy again. All right, now that I've got everything written out, I need to find where they break even, where they are the same. So if you just kind of go down the table, different, this is 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 different, hey, this is the same. So my break even point is at 360. Now, here's the thing. I also know what my X value is. Well, my X value was what? 6. So my ordered pair is going to be X is going to be 6, and then the break-even point was at 360. So the solution to this system of linear equations is 6 and 360. And we can prove this by simply plugging this X in the place of here. 25 times X, what's that give me? Just do a little bit of math on the side. Matter of fact, I'll show it to you right now. 25 times 6 gives me that, plus 210 gives me 360. Did that check? Yep. Let's try the next one. 60 times 6 gives me 360. Hey, did that check? Yes. So this is what the break-even point method is. It's just filling out a table and finding out when it's equal to one another. Pretty straightforward, nothing all that difficult. Let's go on to number 2. It says solve the system of linear equations by graphing. I find this a lot more fun. I just do. All right, so simply put, you're going to graph each equation, and that's it. That's all you're going to do. So you need to go back and think about how do you graph equations. First off, you need to know what you're looking at. So in this particular one, I have my slope-intercept form all beautifully laid out. So right off the bat, I know that my plus 1, for this particular one, I know my slope happens to be 3 and my y-intercept happens to be 1. So I'm going to kind of label this out here. We're going to label these as 1, so we're going to say this is my intercept, and then it sets a plus 3, since that means I'm going to go up 3 and to the right 1. And there is my first point and second point, and now I just draw my line. And this is where the sharp point in your pencil lead needs to be as best as you possibly can. All right. And make sure that you are going. So notice I went up there, and then I could do the same thing in the opposite way. So I have my points. Now I'm going to do the same thing. What's my slope? Well, it's going to be a -2. What's my y-intercept? It happens to be -4. Should be a review on how to do this. So -4 for my y-intercept would be right here. And this time it's telling me -2. And here's my problem. It goes off. But remember this, that we can write slope -2 over 1, or we could write this as 2 over -1. And your job is to determine which one of these is better. Well, if we do rides over run, this is telling me to go down 2 and to the right 1. Well, that's not going to be as beneficial for me, for the simple fact that it goes off my graph. So let's use the different one instead. It's telling me to go up 2 and to the left 1. So there's my point, which I actually already I didn't know that was going to be answered, but hey, there it goes. So we graph our line. All right, now, so we've graphed both lines and I already kind of told you what's happening. Notice where they cross. This is literally being a pirate today. X marks the spot, guys. So what is this ordered pair? Well, this would be -1 because we're counting that. This would be -2. So my ordered pair would be my X value is -1. My Y value is -2. And we can prove to make sure that this works by plugging this number back back into the equations. So we have to prove it. This is what it's just saying. It's just a check. And so we know right off the bat that if I plug 3 times -1, I'm plugging -1 into place of x, plus 1, it should be equal to -2. Does that work out? Yes, it does. So now let's do the same thing with the next equation. -2 times -1 minus 4. It should give me -2. Does it? Yes, it does. So this is indeed a solution. Let's do another one. All right. Now, same concept. We're going to... This time it's going to get a little bit more difficult, and I'll tell you why. Notice that the y-intercept on this is 1, and the y-intercept of this is a -8. And look at our graph. We only go 1, 2, 3, 4. So we actually are going to have to count by 2s in this graph. If you don't want to do that, you may draw this and count by 1s on another piece of paper. And because we have to count by 2s, this is where I was telling you a while ago, it is imperative that you have a sharp pencil and imperative that you have a good straight edge, because this is where mistakes get made when you have to count by anything other than 1. All right, so let's just go ahead and do it. So we know we're going to count by 2. So we have a slope of -4 for the first one and a y-intercept of a +1. So my y-intercept would be right here, halfway point. All right, see where this is already going to probably can mess up pretty quick if you're not exact with what you're doing. Then it says -4. It means that I have to go, so if I rewrote it, it would be -4 over 1. So I would be going down 4, so I'm going to go down 1, 2, 3, 4, and then to the right 1. Ooh, see what just happened? How bad that worked out, because I was counting by 2s, and since I started in the middle, I actually had to go 1, 2, 3, 4. And now that I have it, it's just a matter of going ahead and plotting it and drawing our stuff out. And I want to be as exact as I possibly can. So I've done that. Now I've got to do the next thing. I have a negative, so my slope for this is going to be 5, and my y-intercept is -8. So -8, that would be right here, okay? Well, that one's nice. But now it says I have a slope of 5. So that means it's going to be 5 over 1. So I'm going to go up 5. 1, 2, 3, 4, 5. And I'm going to go to the right one. So again, it's that same spot. So here is where my point crossed. So where did it cross? Well, this was a +1 for my x value and a -2, -3 for my y value. So my ordered pairs should be 1 and -3. So we need to verify that. Just like we verified this solution over here, we need to verify this solution. How do we do it? We plug it back in. So we have -4 times a +1 plus 1. If this is correct, it should come out to a -3 like we have determined. Does it? Yes, it does. All right, so now we have to check the second one. 5 times a +1 minus 8. If we work this out, it should also equal to -3. Does it? Yes, it does. So what's my solution for this thing? The solution is 1 and -3. So this is correct. All right, now, number 4. Going on pretty fast. Pause, you know what to do. You understand how to do things. If you need to come back and see me, come find me. It says, using graphing calculator to solve the system of linear equations. All right, so I did not write this information in your notes. I am going to tell you right now. Write what I'm telling you in your notes, because this is going to be so awesome. You will love this, and it is great. You have a graphing calculator, and it is a wonderful piece of equipment. So, first off, remember that when you get a new calculator, always just go ahead and reset things. We've talked about that before. I'm going to reset everything because I don't know what's in here. And I am going to get these equations into my calculator. And the first thing I need to do is put it y equals form. So this first one's easy. It's already set as y equals this. So it's got 2/3 x. So notice what I'm going to do. I'm going to put that 2/3 in parentheses by saying parentheses 2 divided by 3, then my x button plus 2. So I've got the first one in. So y is equal to 2/3 x plus 2. Now I need to put this one in, but here's the problem. It's not in slope-intercept form, so I need to make it happen. How can I do that? Well, I got to get y by itself, so I have to use SADMAP. So I subtract x on both sides. That cancels out, and I get negative y. Don't forget, that's a negative there. Bring it down, is equal to 4 minus x. So what's technically in front of this y? Well, it's that invisible 1. All right, so it's a negative 1y. So that means I can divide by negative 1 on both sides. And I get y is equal to negative 4 plus x. And I can rearrange this one last time to make it into proper slope-intercept form. This is a positive x, so I can just write it minus 4. So now that I've got it, y is equal to x minus 4, I'm going to put that in there, x minus 4. All right. Now, what we want to do is go to graph. Okay. So what we did while this thing was loading, we had to find both our equations had to be set to y equals, and then we plugged it into the y equals place up here, and then we hit graph. And notice that we got our 2 lines, but here's the problem. We don't see the intersection, so we actually need to do something. We're going to have to hit zoom. All right, so again, I know I'm going through a lot of different things here, but write some notes down as you need to, because this is a very useful skill. Hit zoom. When we do, we're going to zoom out. We want to zoom out with 3. So I'm just going, once I do it, it takes me back to that original screen that I was just at. Just hit enter one more time. And now we see a line being made. And then we see another line. And now this time we actually see where it crosses. So what we need to figure out is, where did it cross? And this is where it's so awesome. It does it for us. Hit the second button and then trace. And what it's going to do is go to second calculate. So we're going to hit second calculate. And what we're going to look for is where the lines intersect. So I'm going to hit 5. Now, look at what it says here. Once it comes back to that screen I was just at, but it's giving you some information. It's telling you the first equation here, and it's asking you for first curve. What it's telling you to do is asking you to choose the lines that you want to figure out where they intersect. So I have 2 lines, and see this little blinker right here? Well, it's on this very first line, that very first one that we plugged in. So that's my first curve. I'm going to hit enter. Now it asks for the second curve, and it puts my blinker on the second line, and that's where I want it to be. So I'm going to hit enter. And then it asks you to guess. And so what you need to do is you need to use your arrows to move it that little blinker as close to where the intersection is as possible. And then once you get it there, hit enter. Give it a moment, and then it tells you that your values happen to be for this, that your x value is 18 and your y value is 14. So your ordered pair should be 18 and 14. Now, is this true? Well, let's find out. Let's black out of it by going to second and quit. And let's plug these numbers into our equations. I'm going to put 2/3 in parentheses by going 2 divided by 3. And I'm going to multiply that by 18. And I'm going to add 2. If this is done correctly, it should equal 14. Does it? Yes, it does. All right, now we're going to plug these original numbers back into this equation, the very first one. So I have 18 minus 14, and this should equal to 4, according to this original equation. Does it? Yes, it does. So does this work? Yes, it absolutely does. All right, so let's go ahead and do the next one with you. All right, so I'm going to go to y equals, and I'm going to plug this stuff in, and I'm going to clear it out by just hitting delete button. I'm going to, going off to the side. Let me show you what I just did. You see where it's blinking on the equal sign? Now you can just hit delete. Not delete, but clear. Oh, this is being silly. Why is it doing this? There it goes. Sorry. Me being foolish. Go back down, hit clear. There it goes. All right, now we're doing right. So we're going to plug this one into our equation. So y is equal to x minus 7. Hey, that's easy. Put it in, x minus 7. The next one we have to rearrange, and we have to subtract x on both sides, and I get y is equal to 3 minus x. Now, we could rewrite this, but hey, there's really no need. Just put it in there. Y is equal to 3 minus x. Now, what did I mean by we could rewrite it just to show it? I could have rewrote it as this. I'm going to move this whole thing over here to put it in proper slope-intercept form. But since we're using our calculator, there's that musical chime again. All right, we don't really have to. Now that we've done that, we're going to go graph. It gives us a line, gives us another line. All right. And this time, you know what? We can probably zoom in on this. So I'm going to, because it's not the best, so I'm going to go to zoom. And I'm going to put it back in standard. This is, we've talked about it before, where it's a 10 by 10. So we're zooming in, and we can actually get a better view of this. Now we've done that, we're going to go second, calculate. I'm going to go to 5, my intersect, and it's asking me for the first curve. My blinker is on this line right here, so I'm going to just hit enter. It's asking for my second curve. It's on the second line, so I'm there. And then it asks me to guess. I'm going to move my blinker all the way down to where it intersects to get a good guess. Hit enter one more time, give it a moment, and it says that my value is 5 and -2. Now that we have done that, let's verify to see if this is indeed my correct answer. Second quick to back out. Let's plug things in. We have 5, x is 5, minus 7. This should equal to a -2. Does it? Oh, running out of room. Yes, yes it does. Now let's try the next one. I have -2, which is my y, plus my 5, and this should equal to a +3 according to the original equation. Do it? Hey, it does. So yes, that indeed is my correct answer. This is all you're doing. It is a system of linear equations. You're graphing it. Once you, like I said, this is your best friend. This method right here is how you can check every equation you will do from here until eternity by using this calculator. All right, so I'm going to leave number 6 for you as a challenge problem, and you know how to find me, and I'll see you in the next video. Bye-bye.